It was basically the type of data and what is RDBMS, Relational Database Management System. What is, I mean, unlike RDS, what we have different kind of database management systems as well. So these things we also learned. I think we all have some basic idea on top of this. We also discuss about in RDMS about the keys. So today I'll be going to focus the keys once more time, and then we will be starting normalization process, data normalization, how we can make a unnormalized data to normalized one. This is very much interesting. You can learn this thing. After that, we will be directly jump to database. It's a relational database. Okay. So we will be installing one database at our system so that we can go ahead with the hands-on part from tomorrow onwards. Okay. So this is the overall part we'll be going to learn today. So the first thing, the keys in SQL. A primary key, you already learned what is primary key. Let me show the thing again so that you can understand quickly. So I told yesterday primary key is the unique row identifier. Just like I have an example over here. Be focused on that. If there is any doubt or any stuck point at your mind, please stop me and ask me question. There is, uh, I mean, if there is anything that is taking you to understand, you can ping me or ask me question. There will be no issue. Okay. So we have a table called student. Table is having 4 column: roll number, name, surname, marks. Okay. So roll number, as of now, I can say this thing is a row identifier because a particular student marks is not repeated. I can also say this name is also a primary key. I can also say because this is, you can see, there is unique combination of name. There is also unique combination of roll number. Pankaj is not repeated. But while identifying a particular columns, especially the primary key, we should not choose this kind of name as primary key. Maybe today we do not have student. Tomorrow we can be another student having the same name Pankaj. Okay, there is no issue. Even in the same locality, same naming conventions are there. So that is why, I mean, always we need to think about the primary key, which should be in this way. Roll number can be a good primary key option because a particular student's roll number can always be unique in nature. If another Pankaj joined with another surname or with the same surname, he or he cannot be having the same roll number. Okay. So the first option, the good option should be roll number. Okay. I hope there is no doubt, but if there is any doubt, please tell me. So roll number can be a primary key. So foreign key we learned if we use the roll number in somewhere else, not as a primary key. How I can declare, let me think, where I'm using student ID or student roll number over here. Suppose I can mention one, fees collected. Okay, I'm mapping it. Maybe teacher ID over here, student roll number here, mm, fees collected. Okay, so each teacher ID, fees collected in months. I mean, student are paying fees for each of the month. Okay, I'm not putting teacher ID. I'm just putting months. Over here, I'm putting transaction ID. That should be the primary key. Okay. So I am creating another table which is consolidating the information of each of the students. Uh, I mean the collection of fees, the school fees. Okay. And the transaction ID is getting put over here. Suppose 1, 2, 3, 4, 5. This is a transaction ID. Month is Jan. Student roll number is 1. The same student I'm mentioning over here for February month. The transaction ID is 1, 2, 3, 4, 5. No, not the same thing. 6. I'm changing the student name to 2 for Jan. 1, 2, 6, 7, 8. 6, 8, 7. Okay, anything. For the same student, I'm mentioning Jan 1, 2, 5, 6, 7, 9. For another student, I'm putting in this way. Okay, this should not be the same one because the same student cannot be paying duplicate fees. Okay, so let's check about the table. This table is collecting information of each of the students' monthly fees collection. So I'm taking student roll number over here, which month they are paying, and transaction ID. For this scenario, you can see we are using student roll number over here, which is not unique anymore because for each of the month's transaction, that should be always repetitive. Okay. For this table, which is the primary key? Anyone? Which should be the unique one? Transaction ID. Correct.
Transaction ID.
Correct. So transaction ID cannot be repetitive. Each student, each month's transaction should be always unique. Excuse me. So that is fine. So transaction ID is the primary key over here. As student roll number is a foreign key over here. So that is the concept of foreign key. You already learned. I'm just going to repeat it once more time. So I think it's clear now. What is primary key and what is foreign key? Now I'm just removing this thing. I'm going to introduce another new thing called composite key. This one. Okay, let me introduce another thing. How I can tell this thing. Hmm. Okay, I'm going to introduce a new column in the student table called subject. Okay, so I'm going to repeat this subject. Suppose for the same student, I'm going to repeat it. This is for different, suppose maths. Okay, so this is the collection of student. Now what I have done, I have included one more column over here, which is roll number, name, surname. The new column is introduced is called subject, and marks was already there. So we also included for the new subjects, the new marks has been included. But this is a valid table. We can introduce this kind of data. Obviously, there is no issue. But you can see roll number is not primary key over here now. Okay. Is it fine for everyone? Roll number is a primary key now or not? It's not a primary key because roll number is repetitive in nature. Okay, 1, 2, 3, 4, then 1, 2, 3, 4. Again, if we just introduce another subject, then again it will be repetitive, but it's valid one. A roll number, a roll number can be repetitive over here because we are introducing other subjects as well. We are not, we can do one thing. We can summing up history and maths marks and omit subject column, and summing up the marks we can take each of the students total marks. Then roll number should be again unique. The aggregation or summing up concept I'll be coming later when we will be going deep into SQL part. But as of now, you can just think roll number is not repetitive. So what can be my primary key in the table? Then the concept should be coming as composite key. When we can think more number of columns, the combination of 2 columns or 3 columns or 4 columns can be unique or not. Okay, so what make my entire data set duplicated now? The subject column. But you can see the roll number and subject combination should be always unique now. Roll number 1 and history, that should not be duplicated. Am I correct? Roll number and history's combination cannot be duplicated. So we can introduce, we cannot tell now roll number is alone a primary key. Rather, I can tell the combination of roll number and subject can be a primary key now. Okay, I'm just moving this thing, changing the order of the column. The combination of these two, I'm highlighting. So this can be this can told a composite key. This is obviously primary key. This kind of primary key is called composite key. When more than one columns can be combined to declare the uniqueness of the record, then it's called composite key. That thing we didn't learn yesterday, so you can check it today. A set of columns used to uniquely identify the rows in a table. It's called a composite key. Okay. So, any doubt? Is it understandable for everyone? Is it fine? Please tell me yes or no, anything.
Yes, it's
Okay.
fine.
Okay. Okay. Fine. So, moving to the next thing. Yeah. Thanks, Sagarika. Okay. Now, we'll be learning data normalization. It's also very, very important concept. Already we covered this thing in last working day, but we are not familiar with the terminology, and we'll be going with some more deep knowledge with that one, normalization. So let's learn what is normalization. Okay. So why normalize is required? Let's first discuss it. So data normalization is a process of recognizing the data within a database so that users can utilize it for further queries and analysis. Okay, so when we are receiving some data in a tabular format or relational database, actually, there can be duplicated as well. Duplicate data can be captured there too, which causes, which is just opposite of data normalization. It's a unnormalized data. So to make data, normalized, what we have to do? Duplication must be eliminated. This is the first point. The data, the entire record. Why? How I can tell the entire record is duplicate? If there is repetition, suppose this record is repeated again over here. This is very bad record. If we have this kind of duplicated record, we will be facing issue in our data analytics part. Okay. So that is why before the analysis means before the visualization tools representation of the data, we need to check, we need to confirm whether there is any duplication or not. There should not be any duplication. If any duplication is there, then the data is very bad. Bad data is here and we cannot do the analysis. Maybe if when data scientist team will be working on top of that, they'll also find the issue. Okay, so the data duplication is very, very bad records. We need to check this thing and we need to eliminate it to make it a normalized one. If we make it a normalized, result should be in smaller database. Okay. Minimize, avoid issues with data modification. And if the data is normalized, it's not only the case the duplicate should be resolved. There is another thing. We can count up it. Let's see one by one how we can form it. But this is the advantage. If the entire data is normalized in nature, the duplicate should be removed. Our query means when we'll be writing SQL query, that should be much more faster. We'll be writing the SQL query and we'll be getting the output. If the tables are normalized in nature, then we can receive the output within few seconds or within few minutes based on the data volume at the backend. Okay. But if the data is not normalized in nature, we type the proper SQL query, that is fine. We executed it, but it will take much more time to return the result, the resulting output. Okay. While doing the data modification, suppose we need to do some modifications. So if the data is already normalized in nature, we should be facing very minimal issues or no kind of issues. But if the data is not normalized in nature, there should be lots of issues. Okay. So let's learn now how we can convert denormalized data to normalized data. So there we are mentioning two steps as of now in our course. The first step is called first normal form. This is the first step towards the normalization. It's called first normal form. And after that, we'll be learning second normal form. As of now, we'll be learning these two. There is always third normal form as well and the higher normal form as well. But especially as of now, when you will be going onboarded in a project, you can see as of now, the basic things we'll be learning till second normal form. If we convert the unnormalized data to second normal form, it's almost, we can say it's a normalized table. Let's see what is the normalization, denormalization table. Then we can convert it. And I have an Excel example for you for the same. Yes. So this is the particular table I have created for you for this demonstration. The table is denormalized in nature. Why? It's not a normalized one. We need to make it a normalized one. Just, as of now, focus on this table. No need to check the other table. So let's check the rule. What is first normal form? This is the most basic form of data normalization, which is called first normal form, which ensures there are no two same entries in a same group. Okay, means sorry. For tables to be in a first normal form, it should satisfy the following rules. Okay, let's see. Each cell should contain a single value. Okay, a cell cannot contain multiple values. So if this is the case, we need to segregate the cell's value into another row. Each record should be unique. Okay, this is the two things we need to maintain if we want to convert a table into first normal form. Let's see. The first thing is you can see this row and this row is totally duplicate in nature. Okay, in this table we are having, storing student ID, student name, what particular course ID he or she is learning from a coaching institution, and what course fees he or she is paying. This information we are keeping in the table. So why I can tell this is not a normalized data. This is totally denormalized data because we can see that there are duplicates. This record and this record is duplicate. And another thing we can see, a single cell can contain multiple elements. Okay, just like Shonu is learning two course IDs. So I'm maintaining two separate course IDs over here with a delimiter, comma. Over here, for the two course IDs, he or she is paying two course fees. That is why it's also separated with some delimiter, semicolon. Okay. So, which is against the rule of normalization. So, we have both of the cases. We need to convert it to first normal form. First of all, I'm going to delete this one. Okay. This is the first step we can do. The second one, we can split this thing into multiple rows just to maintain in this way. 12 Sonu A1 to 800. 12 Sonu A13 300. This one. So we have splitted these two records. This record to two separate records. Okay. Similarly for this one, Raj is learning to different course IDs, paying to different course fees. So we are segregated these two columns. Uh, this particular element into separate rows. Okay. For the other records, I'm keeping it as it is because there is no such multiple values in a single cell. Okay. So I can tell now this table I can able to successfully convert into first normal form from this table because I maintain both of the rules. Each cell should contain a single value which is already there. There is no such multiple values in a single cell now, and each record should be unique. There is no such duplication. You can tell that this thing is duplicate. 12 Sonu, 12 Sonu is present twice. But then you need to check the entire row. Duplication means entire row should be present once more time, which is not there. If you can see the entire row, any rows are not duplicated. Okay. So we are successfully in first normal form. This table is in first normal form. Now, how to achieve second normal form? Okay, one more thing I just want to say. So before going ahead with first normal form, we can tell this was my only primary key. But if it was duplicated, then I cannot say this thing. Earlier it was there. So it was not primary key at first. When I deleted this thing, deleted the duplication entry, I can tell the student ID is the primary key. But when we are segregated course IDs into separate rows, we cannot tell this alone is a primary key. Rather, we can say combination of student ID and course ID is a combination. It's a composite key. We learned what is composite key. So you can tell student ID and course ID's combination can be a primary key. Okay. Now let's check what is the terminologies or how we can make the second normal form. The first criteria, it should be always first normal form. Otherwise, we cannot go ahead with second normal form directly. Yeah, our data set is in first normal form. That is fine. Now, we need to check. This is very much, conceptual. So we need to identify the primary key of the data set. Okay, which we already determined. The combination of student ID and course ID should be the primary key. Okay. Now the other columns apart from this, we need to found we need to find what are the columns, and if there is any columns which is having partial dependency to this entire data set or to this primary key. Student name is not partial dependent. Actually, student name should be coming with student IDs as well as course IDs to check it. But course fee doesn't have a direct relationship with student ID. Course fee is totally dependent on course ID. So if we do not have the full dependency of the column with the primary key, then we can segregate the column with a separate database. So as I mentioned, course fee is totally dependent on the course ID. Okay. So we can segregate this thing, course ID and course fee in a separate table. So when we are segregating, we can take the entire thing just like this way. But over here, you can see the duplications can be there because for each of the students, they are going to repeat it over here. So that is why we need to make it unique again. And this is my final course ID and course fees table. Okay. So we have segregated course ID and course fees in a separate table because there is a partial dependency. Course fee is partially dependent on student ID. That is why I have segregated this. And I'm keep residing only these three in another data set: student ID, student name, and course ID. Okay. Now we have two different data set, but I can say we are in second normal form. This is the thing we learned yesterday session. We have small table, but we have relationship between those two table. You can see we have segregated this thing, but we have relationship because we have the common column course ID. Whenever it's required, suppose my boss can ask me question, how much Pankaj is paying or how much Raj is paying to the tuition center. I just need to check the course IDs along with Raj, A11, A14. Although we do not have the course fees over here, I'll be directly jumping to the table A11 and A14. I can see the involved course fees 500 and 700. With this summing up, after summing up, it will be 1200. So Raj is paying 1200 to the institution. I can directly confirm this thing. So although we have separate two tables, but we are maintaining relationship by these keys. And you may have questions. Although you have in second normal form, the table numbers are going to be increased. So how query will be much more faster? This should be so really much more faster because we should not be having only this many rows. Of course, we should be having when we will be maintaining any database systems in a table, in a live project, there should be lots of rows. Okay, there can be lakhs of rows, there can be millions of rows over there. So if we have large number of rows as well as large number of columns, if there is duplications as well, the database performance will be very slow. The SQL query output should be very slow. But if we maintain the data with this kind of normalization, we can split up the table properly in proper logical way. If we can remove the duplicates, if we remove this kind of partial dependency and segregated the table, whenever it's required, we should perform some join operation. Join means we'll be learning join in SQL. When we'll be learning SQL, join means joining these two table based on the common column. We can get back the data again, which is required as per. Maybe we need some aggregation, just like our Raj's tuition fee, Sonu's tuition fee, A1 to A13. So this should be summing up and giving me the answer. Pankaj's tuition fee, A11 500. So I can directly join and get the thing. Okay. But if we keep residing this kind of table in the databases, that should be much more efficient. And relational database follows this kind of rule. Okay. Yesterday we checked the similar kind of thing in an example that we are I mean, segregating the thing, order table, employee table, I mean, customer table, customer address table, product table. We are having separate table so that we are not maintaining all of the things in the same table. It's, I mean, having much more issues and difficulties when the row numbers are going to be increased daily basis. I have another example over here. Similar kind of thing. Whatever we are learning last day, the same thing we are having here as well. So you can see I have a big table, but this thing is first normal form. There is no such duplication. There is order ID, customer name, customer contact details, customer city, product name, product brand, billing cost. So what I have done, I just segregated this thing to convert it to second normal form. I keep one table called order table. There I'm maintaining order ID. Okay. Okay. First of all, this is called fact table and this is called dimension table. What is fact and dimension? There is detailed things we'll be learning in business intelligence chapters, maybe after 1 week. Okay. Now, as of now, just think this order table is a fact table, customer table and product tables are dimension table. So while segregating from the data set, the dimensions one, just like the customers things I'm segregating from there. So when maintaining the dimension should be unique. The customer name should be unique over here. There should be one entry for each of the customers. So I'm providing one keys for this. This is called customer ID, which is not present here. I'm producing this kind of columns directly over here. Each customer is giving one particular customer IDs as primary key for this table. Similarly, in product table, each of the product I'm giving a product ID as the primary key. Okay. And I'm maintaining the similar kind of primary keys over here, which is playing as the foreign keys role. So over here, we have segregated the entire data in 3 different tables. This table is containing customer data. This table is containing product data and order table is combining all of them in a single table. But we are not maintaining all the customers information. We are rather mentioning the customer's primary key, that is customer ID, which is playing a foreign key over here. Similarly for product ID. Product ID is the primary key over here and it's playing the foreign key. But this table alone can play the entire role. When we required which customer bought this thing, I just directly reach to the other table to check it. Okay, but the storage power, this kind of things are called normalization. We should not keep anything which is have a partial dependency. How do you know we should separate in this way only? Okay, I just mentioned over here. So suppose think order ID is a primary key over here. Okay, this is the bigger order table. So order ID is the primary key in this table. We need to check whether there is any partial dependency of any column on top of order ID. Customer name, yeah, definitely. Customer name is not fully dependent on order ID. The same customer can come tomorrow with another order. So there is no one-to-one relationship with customer name, as well as there is less dependency with order ID. So that should be in a separate one, separate table. Customer contact is also the same thing, but customer name and customer contact should be in same table. Customer CT, the same thing. It should be, it is not direct relationship with order ID. It is having partial dependency or very less dependency. That is why I keep those 3 columns. I have segregated this thing in a separate table. I'm giving them a unique identifier called customer ID. And I'm just keeping customer ID over here in order table. Similarly, product related information. Why I should keep this thing in the same table? This is having partial dependency with order ID. That is why product name and product band, I kept it in a separate table. with having one product ID, and I'm just passing this product ID over here. Billing cost should be a direct relationship. Each order should be having one cost involved with it. So that is why this costing should be always directly tagged with one billing. Okay. So order table, I'm maintaining this thing. Later, we will be learning the business intelligence topic where we will be learning dimensions and orders. Then we should be having some other detailed knowledge on top of this. So as of now, if there is any doubt, please tell me any other person, whatever you have learned. I found 3 more people just joined. So I'm requesting everyone who are going to join the class, please join a bit early at the time so that you should not have to miss the session. Otherwise, you need to just check the recordings again for the beginning. Okay, this is as per the ease. I'm not sure who has joined new, but please join at the time. Excuse me, I'm suffering from some cold and cough over here. That's why. Okay, so any doubts from anyone? It's fine about first
Yeah,
normal
I
form.
have one question.
Yeah. Tell me.
Yeah,
Sagarika, yes, tell me.
based yeah, based on what factors we are deciding whether it's a one normalized form or it's a second normalized form or it's a third normalized form. So when we
Yeah,
are
as of
working
now,
with
we are
large
not going
data
at third
sets,
normal form. Yeah, first of
yeah,
all, this is my source data set, what I have received. Okay. So the first normal form, I need to check first thing whether there is any duplication in any rows. So there is no
yeah, yes, I got
duplication.
that point. But
Yeah.
when we are working with large data sets, we can't see the data with the whole things, right? So we can't see 10,000 rows at a time and we can
Correct. I
segregate the
mean, that
data.
should
So
not be,
yeah,
yeah. For that thing, we need to learn the SQL. We need to type the query. We can quickly check the duplication. So there
yeah,
is, then we need to learn the SQL query. Yeah, over here we are doing the demonstration on top of Excel sheets, and I just put few of the records. But yeah, it's a good question. In a live scenario, there should be 1,000 records, 10,000 records. I cannot see this thing only by our eyes. Okay,
yeah.
so that thing should be always, uh, I mean, SQL query. We need to learn the SQL query, the select queries, and all. And by these queries, we can identify the duplications. Okay.
Oh, yeah, only duplications for first normalized form, right? For second,
Yeah, then we
on that
can
part.
second normal form. We do not need the checking the rows. We just need to check the column names and along with some data, some demonstration of data is fine for second normal form.
Okay.
Okay. Should we need all the records that time? We really do not require. We just need the column name and what kind of data they are having. So there only 10 records is fine for that. Okay. Even
Yes,
we
yes,
have,
yeah.
okay, let me answer your questions as well. So suppose this is my, okay, if it is there, I'm also presenting this thing. So how to check the duplicates in Excel? There is also, I mean, we can also do this thing in Excel as well. Let me just keep this thing on the sheet. Okay, suppose I need to check the duplication. So for the duplication, I need to combine all the data in a single data. This is not the proper way actually to do this thing, but I'm doing a quick concatenation. Similar kind of things we can do in Excel. I mean, a SQL part with much more easier. What I'm doing, I'm concatenating everything.
Mm.
So I'm concatenating the things. Similar things I'm applying for everyone. Okay. I can see this is duplicate, but I'll not suppose I have thousands of records, so I cannot confirm this thing. So I can apply formula over here. Suppose conditional formatting. I can impose some rules or color scales, or I can over here I have the options to check the duplicates. Highlight cell rules, duplicate
Yeah,
values.
duplicate value. Mm.
Okay. So this way I can duplicate, check the duplicate things as well. Okay. This is just, as per your question. But the SQL,
Yeah.
it's very easy for SQL. When we'll be learning
Yes,
SQL,
yes.
I'll be showing if we having thousands of records, we can simply put the SQL query is very, very helpful for that one to handle the
Yeah.
entire SQL database. Relational database. Okay. Just give me 1 minute time. 1 second. Okay. Now we'll be moving to the technical stuffs. Database. Database is where we are residing the data in tabular format. Database means I'm talking about relational database. We should be actually in our project we will not be keeping the data in Excel because we should be having large number of data. Even Excel's performance will be very 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 slow if we going to analyze in this way. So that is why the database concept coming into the picture. Database is nothing but it's a large repository where we are keeping data in tabular format. Okay. So this is called database. There are lots of databases in market, just like MySQL database, Oracle database, Microsoft SQL Server database, Teradata, Postgres, Sybase, DB2, Redshift, Snowflake, many other databases are there in the market. So why we are different databases based on the requirement of your project. Okay, so based on your requirement of the project, there are separate different databases along with their different features. So I'm going to launch my project. Suppose I'm a product owner. I'll be going to discuss with my architect who is architecting the project. Architect means they should be having uh, 15 years of experience in data field. So there we can call them as data architect. So we are discussing with them and we need to think about this is my requirement. I need to keep this many records. So what should be the good idea for a database launching? What kind of database I can launch? Okay, I need to also check my costing part as well. So each database is having several cost. Some of them is having cloud facility hosted in clouds or just like this. So based on that, my architect will decide or collaborating the things with product owner and the database is getting launched. This is as per the project. Okay. So, but over here we'll be learning one of the databases. Let's learn MySQL database. But let me tell you, if we are learning one database, we are learning SQL language. It's more than 95% similar. The SQL language is 90 to 95% similar for all the databases. But for each of the databases, it's having some inbuilt functions. Okay, suppose I'm doing some function operation on top of MySQL. The similar kind of functionality is present in Oracle as well, but the syntax is a bit different. Okay, but do not worry about this thing. You are learning a SQL language. When you are totally, you can able to understand the thing. You can quite comfortable to check the similar kind of functionality over here by searching in web or whether you should be having the knowledge on top of that. So learn SQL language in any databases and you can learn, you can do the SQL query for the other databases as well. There are very minimum changes. I'll be showing what can be the changes during learning the SQL. Maybe I'll be showing some examples as well to you, but this is very, very minimal. So get confident with any of the databases. So if you have any databases installed at your system, that is fine. No need to uninstall. You can go ahead with the demonstration at your system. Whoever do not have any databases installed at your system, I'll be recommending you MySQL, installing MySQL because this is open source free software. So for this, just visit this particular link. I have the link handy over here. Yeah, let me copy. This is MySQL database. It's also Oracle product, I believe. Yeah, it's a Oracle product. So just go to this thing. I hope everyone is having Windows operating system. Download the second one. This one, the big installer part, 285.3 MB. Okay, although it's not big, it's very light software. So I'm just giving this link to all of you. Please install this in your system because tomorrow onwards we'll be learning the hands-on part on top of database. So when we are installing it, there are 3, 4 files should be installed over there. Just like the database itself, MySQL database. Now with this particular database, a particular workbench is also installed in the package. What is workbench? Workbench is just like the UI part, the user interface part where we can write the SQL command. I can also run the SQL command in command line, but this is not a good approach. I mean, not good user interface. This is like a Unix box kind of stuff. Okay, let's learn the thing in Microsoft. I mean, MySQL Workbench. If you're installing this thing, all the files will be installed in your system. I'm going to launch MySQL Workbench. Daily basis, I need to authenticate my user, giving the password. I just logged in there. So this is called a database. In the database, I have segregated the database with various database schemas. Those are different database schema. Okay. So for each purpose, suppose I'm testing something. So I'm going to test into this database. I'm going to create the tables over here. Suppose for my tuition purpose or for my courses in Tetra data training over here, I'm doing my activities over here in these database schemas. So inside the database, this is called database panel in the left hand panel. Okay, where I will be residing all my tables. The right hand side, it's query editor, where we can put the queries. When I'm running the query, this should be my output. Okay, output of the query. Those are the rows. Several rows are present over here. Okay, it's very simple. This is administration part. The admin team who is managing the database is called database administrator. They generally follow this. But as of now, we are the admin because it's installed in my local and I can control everything in the database. So I can do administration part as well as my database engineering part. But when you are live in a project as a data engineer role, there you can see uh, you are doing this kind of development part or doing the coding part over here. But some other team is managing the database, means where the database is hosted. Okay, so the DBA team should be a separate team. They are managing the database. They are not the data engineers, they are the DBAs, so they are maintaining this thing. I'll tell this thing again separately during learning the SQL part. So as of now, uh, please install the thing. It should be looking like this. And when you will be installing it, at the first time, they will be asking for the password. Password is nothing but your database is to authenticate your database, the password is required. So when you are giving the password, just recall the password. Remember the password because each time daily base when we will be logging to our database, the password is required. Okay. Just like I'm logging in over here. Okay. So please, while installing this thing, please recall or remember the password. Okay, install it at your system and we'll connect again on tomorrow's session. Any other thing? What is database schemas? I just mentioned over here. The left hand thing, those are separate database schemas. Means we are segregate the based on different subject areas, we are segregating the database. Suppose I need to create another schema. I can just right click on any one schema, create one schema over here, create schema. Okay, I'm just putting any schema name A, B, C, D, 1, 2, 3, 4. Okay. If I want to make it a default schema, then I just need to check it. Otherwise, I just can apply it. I can also put this kind of command over here in the query editor and run it. Okay. Because we are just doing this thing from UI side. So this thing is possible and I can apply it. Finish. You can see a new schema has been created. ABCD 1, 2, 3, 4. The similar kind of thing, I can also do this thing from the query editor. Create schema. I can put a schema name. Suppose similarly A, B, C, D, E, F, G, H underscore 1, 2, 3, 4. I'm going to execute this command. I just executed. It successfully executed. I just refresh it and you can see this is my new schema created. So I can do both kind of things. I can put query editors. I mean, in query editors, I can put the command line over here and execute it. This thing will be generated. And I can also do the things by doing some clicking over here, create schema, alter schema, this kind of thing. But as of now, the most of things we'll be doing over here only because we are going to learn the SQL language. So we'll be doing this thing over here by writing the codes and all. Okay. This schema is not required. We can drop it. Drop schema. Drop now. Or we can drop it from here as well. Drop schema, schema name. Yes, it's dropped. If I'm going to execute it again, it's already dropped. If I'm going to execute it again, it is throwing error because can't drop the database schema. Database doesn't exist because I already executed it a few seconds earlier. It's already performed the things. So if I'm going to drop it again, it's throwing an error log. So at the below, a error log will be pop up. If there is any error, then the log will be pop up. If I just click on here, it will not pop up. For the successful one, it generally did not pop up. For the failure one, it should always pop up. If I just click over here, this thing should be always present. Okay. Suppose I'm running this one. It is running as well as the log has been pop up that I run this query and it returns 21 rows. Okay. But as I'm not able to see it properly, so that is why for ease of my purpose, I just click on here so that I have a full screen for the output. Whenever any error message appears, suppose this one, if I'm going to drop it again, it's already dropped. So it will be throwing error with the error code. The log will be popping up at that time. Okay. Okay. What are several database objects? In the left hand side, in each database, you can see there are tables, views, store procedures, functions. So those are different database objects. Table is the basic unit. We will be mostly doing the part on top of tables as of now. Okay, we'll be learning what are tables, how tables should be created, how to manipulate data inside the table, how to analyze the data over there. So table is the basic unit part and we'll be learning mostly the things on top of table. When table is finished, we will be learning views, store procedures, functions one by one. Those are also database components, but those are also created from the tables itself. So tables is the most important thing. After learning about tables, we'll be proceeding with views, store procedures one by one. But definitely, I mean, that should be created on top of tables only. Okay, so tables knowledge should be gathered first. Based on the tables, we'll be creating such some views, Okay. So this thing we'll be learning one by one. Those are different database objects. Okay. Any doubt so far from anyone? Anyone is having any doubt? No doubt. So please install the software at your system. Yeah. So please install the software in your systems and we will be starting the hands-on part starting from tomorrow. Okay. We'll be learning the languages one by one and it should be much more interactive as well as much more technical stuff. So we'll be learning from tomorrow onwards. Okay then. Thanks everyone.
Yeah. Can you please share the link?
Yeah. Yeah, I shared the link over here. You can find in the chat. I'm just pasting it once more time. Okay, it's going to Gayatri. Just give me some seconds. I think
Yeah.
now everyone can see it.
Yes, thank you.
Okay.
What
So
time
please.
is the class daily? Actually, 7 o'clock or 8 o'clock?
Yeah, Monday to Friday evening.
It's today it's mentioned 8 p.m. CST. So I just joined.
No. It's quarter CST. I cannot convert. Okay, let me just check once more time.
Exactly. Even I got the same confusion. It
Okay,
shows
let me
that 8
confirm it.
p.m. in the CST.
Okay.
Okay, IST timing I can confirm. It's starting from 6:30 Indian Standard Timing, 6:30 to 7:30
So it's
AM.
7 p.m. So 7 p.m. CST.
Yeah, please convert it accordingly and please join.
Okay.
So the time is 6:30 Indian time to 7:30. So we are going to end it
So in
now.
the chat, yeah, so in the chat it mentioned that it's 8 p.m. So I just
Yeah, so
joined.
I just joined. Yeah.
Sorry, I'm not sure. This is maybe having Trishul. I mean, there's some admin team member of Tetra. So if you have any direct
Okay.
contact with them, you can please tell them to change this kind of timing so that there is no such confusion should be there.
Where can we find the recording sessions for today's class?
Yeah, after the ending of this session, I'll be going to hand over this session to one of the admin team member of Tetra.
Yeah, yesterday's class also.
Yeah, yesterday class also I haven't provided yet. So I'll be providing these
Okay.
2 classes today and yesterday's class to some
Okay.
admin member. And he will be going to upload the same in some link. Okay.
Okay.
And you
Okay.
can able to visit this thing. Also, you can ask this question to WhatsApp group to get the updated link where you can find the recordings. Okay.
Okay. Yeah.
That can
Thank
help
you.
you. Okay, then thanks everyone. Let's connect tomorrow with some, I mean, those technical stuffs and all.
Sure.
Thank you.
Thank
Bye
you.
bye.
Have a great
Thank
day.
you.
Yeah,
Have a great day.
thank you.